When we're proving identities, we want to start developing some strategies to do this. And one of the strategies to prove an identity is true is getting a common denominator and see if we can make the denominators look the same, then usually the numerators will follow. So in this case here, I have a binomial on the left side and I have a monomial term on the right side. So I'm going to combine these. I'm going to just add the left side to make it one term. So I need a common denominator to do this. So I need to multiply this by sine x on top and sine x on bottom. So I'm going to do this more formally. So I have 1 over sine x cos x minus sine x over cos x. And I'm going to multiply the top and bottom by sine x to get my common denominator. Okay, so in the next line here, I'm going to show that I have 1 minus sine squared x, and that's all over sine x cosine x. On the right-hand side here, this is going to be cos x over sine x. That's my identity for cotan. And I want to get a common denominator on this side, so I'm going to multiply by cos x on top and cos x on bottom. So on the right hand side here, I now have cos squared x over sine x times cosine x. I know the denominators match, so I know that the numerators must also match. And in the numerator, there is an identity. 1 minus sine squared x is equivalent to cosine squared x. So I'm going to replace the numerator with cosine squared x, and I end up with sine x cosine x. So now I have the right side equal to the left side. That identity is proven. And again, this is only one way we could have done this. There's many different ways this could have been done. In fact, if you look at the left-hand side, there's a common factor of cos that would have canceled out that would have made it equal to cotan. So I could have just worked entirely on the left-hand side and made the left-hand side look like cotan, and that would have also proven the identity.